Alright, so today we're going to talk about special right triangles. And special right triangles are the triangles that you learned in geometry. So we're going to talk about primarily, or not primarily, but only two types of special right triangles, 45, 45, 90 and 30, 60, 90. So the first of which we're going to call 45, 45, 90. If you draw a 45, 45, 90 triangle, notice that when you draw two angles that are same, you're going to guarantee that two sides are the same. And since this is also called a right triangle, we're going to call this an isosceles right triangle. So when we do isosceles right triangles, we can label the sides across the 45 as x, across 45 as x, that makes sense because they're the same, and across the 90, x root 2. So across the 45 is x, across the 45 is x, across the 90 is x root 2. Okay, so let's do an example. If YZ has a length of 5, so I'm going to label this as a 5, we want to fill in the lengths of the other two sides. So this is 45, 45, 90, so label x, x, x root 2. And notice that on this side right here, you labeled two things. So you're going to label it as x and 5. Therefore, you can say x equals 5. So if x equals 5, then you can say, well, zx is just x. So zx, side zx is equal to 5. And yx is equal to, if we plug in the 5 here, you're going to have 5 root 2. Alright. Next example. If JL has a length of square root 3 over 7, so now I'm labeling this as square root 3 over 7. Find the lengths of the other two sides. Once again, label x, x, x root 2. This is the side I have two pieces of information about, so I'm going to set it equal. So x equals square root 3 over 7. Therefore, LK, which is just x, it's just x, so I can say, well, LK must be square root 3 over 7. And JK is, so now notice that it's x root 2. So when you plug in x, which is square root of 3 over 7, so if I plug in square root of 3 over 7 and I multiply it times root 2, I am going to put that over 1. You get a final as square root 6 over 7. So that's what JK is. Go ahead and cross that off. Alright, so 30, 60, 90s. So 30, 60, 90s, this is the smaller angle, so it's 30. This is the 60 and the 90. So you label across the 30 as x, across the 60 as x root 3, and across the 90 as 2x. So let me label my triangle. So across the 30 is x, across the 60 is x root 3, and across the 90 is 2x. So that's how I'm going to label these triangles. So if SR has a length of 7, so here's SR, it's a length of 7, fill in the lengths for the other two sides. So now I'm going to label my sides as x, x root 3, and 2x. Right here, I know two pieces of information, so I'm going to set x root 3 equal to 7. Now this is a much harder example because you don't have just x equals. You have x times the square root of 3 equals 7. So you're going to have to do some algebra because you want to get x by itself. So divide by the square root of 3. So that cancels. So we get x equals 7 divided by square root of 3. Now we talked about yesterday how we have to rationalize denominators. So I'm going to multiply times root 3 over root 3 to get a final answer of 7 square roots of 3 over 3. And I say that's final. That's final for x, which is st. So st, I do already have an answer, is 7 square roots of 3 over 3. Now RT is 2 times x. So if I take this 7 square roots of 3 over 3 and I multiply times 2, I get 14 square roots of 3. So RT is 14 square roots of 3 over 3. Okay. Alright, so RT has a length of 2 root 5, and we want to find the lengths of the other two. So let's label x root 3, and 2x. This is the side I have 2 pieces of information about. So I'm going to say 2 root 5 equals 2x. Divide by 2 to get x. So x equals square root of 5. So x, which is just st, must be square root of 5. And s times r is x times square root of 3. So I am going to have to do a little bit of math here. Do square root of 5 times square root of 3, which is square root of 15. So SR is square root of 15. Okay. And if AT is 2x square roots of 7, so 2x square roots of 7, find the other two. So label x root 3, and 2x. Okay, so I know 2 pieces of information right here. Now, this is interesting because I have x root 3 equals 2x root 7. So it says express in terms of x. So do I solve for this x or do I solve for this x? So since I'm looking for CA, I'm going to want to solve for the x that's part of the ratio. If this is going to get too confusing for you, you might want to use something besides x. Maybe, let's say a. So let's say I had labeled this as a root 3, and 2a. So now I have a root 3 equals 2x root 7. So I'm trying to solve for a. So I will divide by square root of 3. So a equals 2x root 7 over root 3. Rationalize it to get 2x root 21 over 3. So that's CA. And then times that by 2 to get 4x root 21 all over 3. Okay. If BT is 4, find the length of CT. So this question is actually going to be one of the harder problems in this day because CT is right here. And that's what I'm looking for. But I can't go from this bottom triangle to this top triangle directly. So what I'm going to have to do is find AT, and then using AT, use this triangle to find CT. So right now, let's just look at my triangle I'm highlighting in green. So this is going to be x root 3, and 2x. So x root 3 equals 4. So x equals 4 divided by root 3. So x equals 4 root 3 over 3. So that's just x though. So that's right here. Now multiply it times 2 because that's 2x. So that's going to be 8 root 3 over 3. So AT equals 8 root 3 over 3. So now I can redo all of my work here, kind of. And what I'm going to do is I'm going to delete this. So now I'm saying that AT is 8 root 3 over 3. And now I'm using this triangle. Okay? So we have x root 3, and 2x. So I'm looking at this side right here. So I have x root 3 equals 8 root 3 over 3. Now this looks like it could be really complicated. But if I put this over root 3, what I do on one side, I must do on the other. So put this over root 3. You have a root 3 on top, and we have a root 3 on bottom. So this cancels out to just 8 thirds. So x is equal to 8 thirds. So this is x. Multiply that times 2 for a final answer of 16 thirds. Okay, square is a diagonal of 17 square roots of 2. So here's my diagonal. And that diagonal has a length of 17 square roots of 2. Now, if you talk about a square, square is 90 degrees all around. So if you cut this in half, this is 45, 45. So if you just want to draw the triangle, this is 17 square roots of 2. And our triangle is 45, 45. So it's x root 2, and I'm not even going to really do the math here. I mean, if x root 2 equals 17 root 2, then x just equals 17. So that represented each side of my square over here. So this side is 17, 17, and 17, and 17 times 4, which is 68. All right, and lastly, altitude of an equilateral triangle. If you have an equilateral triangle, that doesn't help you much because it's going to be 60 all the way around. But we want to know the altitude anyway, so let's go ahead and cut that triangle. And when I cut it, now I've created a 30, 60, 90. So this is the 30, this is the 60, so this is x root 3 and 2x. Okay, let's go back to our problem. The perimeter of this whole thing is 21. Then this is 7, 7, and 7, which makes this 3.5, or you could say this is 7. It doesn't matter. Either way, this is going to be 3.5 roots of 3. All right. Homework is online.